right, so last time we were talking about mixtures, and we wrapped up in a bit of a rush talking about heterogeneous mixtures and how they can consist of more than one phase. And in the sense of phase here, we're not talking about like phase changes, solid, liquid, gas. A phase would be like a layer or a part. So the phases in oil and water, for example, you can clearly see the oil and the water layered on top of each other. But like in granite, for example, and I'll show you a picture of that in a second, you can see phases or pieces inside of it. So that would definitely indicate a heterogeneous mixture, whereas a homogeneous mixture would look consistent throughout. And in this case, the oil is less dense than the water, so that phase, and they don't dissolve in one another. They're not what's called miscible, and so they separate. So this is just some examples. So believe it or not, blood is a heterogeneous mixture. We would not trick you on a test with that one because technically looking at it, it looks homogeneous, but if you actually spin it in a centrifuge, it separates. And the parts are pretty large. The red cells separate from the white cells and the platelets, and then you have plasma, which is a liquid part. Granite would be a good example of a heterogeneous mixture because you can literally see the phases or pieces. And copper sulfate is a liquid solution. Remember, solution can be another word for a homogeneous mixture. We usually think of liquid solutions, but alloys of metal like steel or 14-karat gold or sterling silver are also homogeneous mixtures and can also be called solutions. So in our very last section, we were going to talk about how do we separate mixtures. Remember, mixtures can be separated into their components by physical means. In other words, you don't have to do a chemical reaction. And there are some specific scientific ways we can do that. Now, we could decant or just pour off, say, oil, or physically pick out pieces when we have a mixture that's very obvious, like these. So you could cool the mixture so that it's a solid, like this bacon grease, and then you could filter it out. There's a lot of things that you could do. We're going to go through some, though, that you may not be as familiar with. So decanting or physically separating, like separating the M&Ms into different colors from a mixture. Of course, those are ways we could separate mixtures. So here again, these are easy ones, right? You can easily pour off a layer here. You can physically pick out pecans here. But other mixtures are a little difficult to separate. But you can still separate them into their components using physical means. So here's an example with blood. Remember I told you blood is actually a heterogeneous mixture. And you can see that when you spin it in a centrifuge, heavier things sink to the bottom, and blood actually separates with the red cells on the bottom, and then the white cells and plasma at the very, very top. So these are some more scientific ways. So filtration is based on particle size. So for example, I could separate big rocks from sand using a filter where the sand would fall through. I could also use a filter to separate, say, sand in water or mud in water and use filter paper. The water would come through and it would capture the particles that were too big to pass through the pores of whatever the filter was. And again, we could use a big filter like this that's mesh, or we could use a filter paper that would filter tinier particles. So filtration would be specifically based on two particles that were completely different sizes. A second one is called distillation. This is usually for purifying water or gases. This is literally based on the boiling points. So remember, boiling point was an intensive property of matter, and for example, water has a different boiling point than alcohol. So if you had a mixture of water and alcohol, you could heat them in this special apparatus. And what would happen is when alcohol, I believe it boils at something like 88 degrees, but water doesn't boil till it gets to 100. So when it gets to 88, the alcohol would boil. This is locked, so it's trapped, and it goes through here. This is called a condenser, and it's got cold water flowing around it, and that would cause the alcohol vapors to turn back into liquid and then drip into here. This is called the distillate. So then you could collect your purified alcohol and the water would be left behind. You could also separate, for example, octane from gasoline this way, because octane would have a specific boiling point. So you would boil until you got to exactly the boiling point that you know is the boiling point of octane, and then put your beaker here, and then you would collect all the octane. And as soon as you saw the temperature going up again, you would know all the octane had boiled out, and now whatever's left would be impurities. Usually you're going to separate 2 or more liquids. You could separate something like sugar and water this way if what you wanted was the water. If you wanted the sugar, that would probably not be the method you would use, but say you had like sugar water or salt water and you specifically wanted to get rid of the salt and collect the water, you could do that. The water would boil, the salt would stay behind, and you could collect the water. The next one is crystallization or evaporation. So this one, so if I had salt water, say, or sugar water, and I just wanted the solid, so the salt and the sugar would be dissolved, if I heat it up or even just left it to sit until the water evaporates away, what would be left, the crystals that would be left, that would be pure salt. Or if it was sugar water, that would be pure sugar. That's how they make like rock candy, for example, or those little coffee stirrers that have sugar along them. So this is a little different than distillation, because here I would be losing the solvent, the liquid. It would float away, but I would collect the crystals. So if that's what I wanted, if I wanted the salt or I wanted the sugar, this would be my choice. If I wanted to collect the liquid, I would want to use distillation. All right, and one more, and we're actually going to do this one in class. This is called chromatography. So you put the substances, in this case, we're going to be using what's called chromatography paper, and you put it in a liquid, and you put a dot of the solvent that you're interested in separating. And in this case, it's pigments of different colors. And for example, marker, you could separate ink. So you may know if you've ever dripped water on black ink, it separates into these colors, because black is not actually a color. It's a mixture of individual pigments, and each pigment has its own weight. And so in liquid chromatography, you put the pigments on a paper, you put it in a solvent at the bottom here, and as the solvent travels up the paper, the pigments start to move up the paper too. But heavier ones are going to be slower because of gravity than the lighter ones. So you're actually going to see separation. In this case, this green at the top would be the lightest pigment, and this yellow here at the bottom would be the heaviest pigment. And so this can also be used to separate different gases. There's such a thing as gas chromatography, but we will actually be doing chromatography in class, and we'll be using marker ink, so you can see how marker ink can be separated into different colors. And you can use different solvents, in other words, different liquids. For example, permanent marker, as you know, is kind of resistant to water. So if I just put permanent marker on this paper and I put it in water, I might not see much of anything happen because permanent marker doesn't dissolve in water. So I might not need to change what liquid I use to get it to move. So we're going to play a little bit with that on Thursday, and you'll see how chromatography works. All right, and this is just a little summary of matter. So matter can be split into 2 general things here. We can have mixtures, and then we can have pure substances. Now, mixtures can either be homogeneous or heterogeneous, and pure substances can either be elements or compounds. Heterogeneous mixtures are not uniform. They're made of different parts, whereas homogeneous mixtures would have a single phase, so they would look the same throughout. They are also called solutions. On the other side, elements are made of atoms, and of course each atom has a nucleus and protons, neutrons, electrons, which we're going to talk about actually in further chapters, so you don't have to know these detailed parts of atoms just yet. And then compounds can be broken down into elements. Remember, a compound is a mixture of 2 or more different elements. Remember, compounds are composed of molecules, and technically an element could consist of molecules. I went over this with you, just a reminder. For example, O2 is an oxygen molecule because it's 2 atoms, but it's a single element. Whereas H2O, water, is also a compound, and it's a molecule. So O2 is a molecule, but it's an elemental molecule, sometimes called a diatomic molecule. Whereas H2O is a molecule but it's a compound, not an element. Some elements are found just as single elements. Some are found as molecules. So they could be individual atoms or molecules. Compounds are always composed of molecules, since it's two or more elements combined. And that wraps up our chapter on matter.